The master thesis, higher resolution camera for an imaging rover, and low-cost GNSS setup for water equivalent of snow cover determination, treats two topics, which are both based on GNSS technology. Real-time kinematic GNSS allows to achieve higher accuracy. By sending correction data from a base antenna or a virtual reference station to a rover, phase-based GNSS solutions can be solved. First, the focus is on the high-end GNSS rover, Leica GS18 I, with a built-in 1.2 megapixel camera. By sensor fusion, measurements of inaccessible points are enabled by photogrammetric forward intersection. The resolution of the built-in camera is below average. Therefore, a measurement setup is realized and a workflow designed for integration of a higher resolution camera with 12 megapixels. The 12 megapixel FLIR camera on a metal plate has a Sunex objective. The plate prevents slight vibrations over the camera, and is needed to integrate the camera into the mounting of the measurement setup. The mounting is made by a square pipe, and is fixed from underneath to the Leica GS18 I. Inside it, the camera is mounted overhead with the help of the metal plate. The workflow contains three main stages. First, the measurement must be brought into a ready-to-measure state. Then, the data acquisition can be started. But, a clock must be captured. At the moment, it is necessary for merging both image datasets. After, the images can be processed in Remote Points app and the single-point measurements done. A first assessment indicates an accuracy gain of 40 to 50% by the higher resolution of the FLIR camera. Now, the focus is switched to the second topic of the master thesis. The goal is the determination of the water equivalent of a snow cover by RTK-GNSS. However, instead of using high-end equipment, only low-cost GNSS components and standard software are used. The water equivalent of snow cover is the amount of water left after melting the snow cover. Traditionally, manual observations, snow scale or georadar are for instance used. More recently, GNSS has been assessed suitable as well. To assess water equivalence by GNSS, antennas are used in base rover mode. One antenna is underneath the snow cover and defined as rover. The other one is above the snow and used as base. The water equivalent of snow cover, now, corresponds to the difference of the reference up component and the measured up component. A low-cost measurement setup has been installed in Davos with 2 GNSS antennas and 2 receivers. It is used to evaluate in-depth findings from March 2021. It was found that the water equivalent can be monitored by real-time kinematic GNSS. Therefore, the setup is observing its up component at 1 Hz during the whole snow season. Additionally, the raw GNSS files are stored to process them later on. Now, only the logged up component is relevant during November and December 2021. The results are promising. The determined water equivalent of snow cover do scatter, but the ones by up component do fit better the manual observations. Further, heavy rain led to problems at the end of 2021. However, the remaining snow season must be logged to assess the method's full capacity for water equivalent of snow cover determination. All in all, the results of both topics are promising.